What is the most used man-made material on Earth? You guessed it, it's concrete. Look around, it's everywhere. You see it in sidewalks, driveways, foundations, floors you stand on, and even entire structural building frames are made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. Thank you for joining us for another episode of Concrete Logic. Today, I am so lucky to have Stephanie Hampton on the podcast. Stephanie, can you introduce yourself and your company, please?
Hi, yes. So I'm Stephanie Hampton. I work for Lehigh Hanson. I work as a senior technical sales engineer in their Mid-Atlantic region, working with their cementitious products. My background is chemical engineering, and I have a background with working with admixtures, cement, stone, and gravel, as well as a long background as well in concrete quality control. So cement seemed to be the right fit. So I've been enjoying it. So
right. We've been talking for a while before we hit record, and you're being very modest. You're you are the you got a very unique background and very in all different parts of ready mix that we were talking about earlier. And like I said, I hope you like doing this, because I would like to have you on the podcast again, even before this one gets going. But so today I brought you on because the latest I guess thing that I've been trying to learn about is this Portland Limestone Cement. And I actually looked it up on LinkedIn, and your name popped up, and I looked, and then you were doing a ACI presentation up at the national chapter. And so I wanted to get you on the show and learn more about it. So could you introduce us to this Portland Limestone Cement, and maybe give us a little basic background on what cement is, cement versus concrete too, because I know a lot of people don't understand that. So let's clear that up as well.
Yes, please. That is definitely something I'm passionate about. So cement is the powder, the reactive powder that you would actually put into concrete. So concrete is cement, water, sand, stone, and admixtures. So without all of those combined, you cannot actually have concrete. Cement is just the powder that's going into it. So a little bit of a difference there. And as far as cement versus, a typical or ordinary Portland cement, which they call OPC, versus the Portland Limestone Cement, or referred to as PLC quite often, the biggest thing is knowing, I guess you could go through the background in how it's made.
Yeah, that'd be great.
Kind of the biggest difference. So one key thing to know is that with cement, the main ingredients for making the clinker that's utilized, or just making it in general, is you can think of the name Lisa G. So the Lisa that goes into the clinker is L is for limestone, I is for iron, S is for silica, and A is for alumina. And then the G is separate for the gypsum. So the reason that it's like that is because initially, a cement producer will mine the materials that they're utilizing, and then they're going to blend everything and then grind it. So it's in that initial grinding process that you're going to have your Lisa, your limestone, iron, silica, and alumina. And then they burn it, and then they grind a second time, and that's when you introduce your gypsum. And then you're good to go. So with Portland Limestone Cement, say that Lisa gets married. So now she is Lisa GL. She's got a hyphenated name. So what that basically means is you do your initial clinker with the Lisa in the beginning, and then you do in the second grinding is where you can add up to an additional 10% limestone in with your gypsum. So really that's the only difference. You already have up to 5% limestone in the initial clinker process, and you're just potentially adding up to 10% more. So it's not that big of a difference. It's something that actually has been around for many, many years in the US for over a decade, but we've been a little slower to accept and move on with things here on the East Coast for a little bit there. But
those components in the aluminum, the gypsum, the iron, are those produced to make the cement? Or are we using recycled material already, material that's coming from byproducts of something else being made?
it depends, and it's completely different with each, not even with each cement producer, but with each cement plant. So for instance, Lehigh Hanson has multiple plants, and each one is going to have either their own quarry where they're mining their own materials, or others where they can recycle others, or even use alternative fuels. But each plant is run differently and has different materials to it. So one of the things that you could get from each of your cement plants for your particular product, you can get actual lead, information as far as the amount of material that's being recycled in those components to make the cement itself. So each one would be different.
Okay.
Mm-hmm.
All right. So that kind of explains how cement is made. And we talked about to make the Portland limestone cement, you're just adding more limestone in at the last step. Is that correct?
Yes.
That's correct?
Yes,
okay.
Exactly. And then so for another term that you might hear pretty often with PLC, you might also hear it often referred to as 1L. It's the same exact thing. It's just that 1L is what the ASTM notation for the type of cement that it is. So it 1L or PLC meets ASTM C595 or AASHTO M240. So for that, they consider it a blended cement because of that additional up to 10%. So you could have, so that's why it's, instead of being like your ordinary type 1-2 cement, for this, it would be a type L, 1L, or you could have a 1S if it was blended with slag. So that's just really what that stands for. And some people may also ask, because oftentimes engineers will refer to the C150. And the biggest difference there is, again, just the amount of the additional limestone. But there's already limestone in ordinary cement. So
right.
It's kind of cool. And it's a 1-to-1 replacement. Now, for us, one of the big things also with C150 is sulfate resistance. And we do actually test our 1L, goes through a 6-month process of actually testing it and making sure that it meets that sulfate resistance requirements. But it's up to each producer and each plant. So it can be interchangeable. And that's, I guess, kind of the message that we're hoping to be able to share, is because you can have this additional up to 10%. With limestone, you're having a reduction in up to 10% in your carbon emissions. So, and it's a 1-to-1 replacement with a type 1-2 for cement for concrete, which is great. I mean, you don't have to make any adjustments to your mix designs. You don't have to change, your admixtures, your water, your aggregates, anything. And you don't have to change anything as far as equipment. I mean, you have a silo. You basically just can utilize the 1L as a 1-to-1 replacement for the type 1-2. So it's an easy way to reduce your carbon emissions pretty much as seamlessly as possible. So it's pretty exciting.
Cool. Can you jump back to the sulfate resistance test? Why is that important?
So typically that's something that engineers have required. And oftentimes they actually will require that. So that's their C-150. They'll typically have that requirement. So cements can have up to moderate to high sulfate resistivity. And it's typically only required if there's some type of exposure for a particular project. So an engineer might specify that. So if you have an issue where, typically you'll need to utilize, an SCM, a supplementary cementitious material like slag or fly ash to assist with mitigating that. And you can have that testing with 1-2. Now, not all 1Ls do, just because they're not, maybe the producer or that plant doesn't necessarily run that testing. We happen to have, just to be able to meet that specification. So I think there's guidance, or there's like the building code, I want to say it's ACI 318, I believe, is the building requirements for the structural code. So, and if there is no sulfate exposure, you don't necessarily need it, but each one will have to clarify whether they have sulfate, if it's moderate sulfate, high sulfate, and if it can work for your design.
Gotcha. And then the 10% threshold for limestone, is that just because if you go beyond that, then you start seeing maybe some detrimental repercussions to the ready mix, or?
No, I think so. This was where tons of testing had been done, basically between, from the 5% and on, and the 15 was kind of just the sweet spot. So as far as performance and being a like to like with the type 1-2, as far as, placement, finishability, strength, and things like that. I mean, oftentimes you can even have better performance with the 1L or the PLC. So it was kind of that sweet spot. Now, again, every plant is going to be different based on how the plants run and their efficiency. And how their materials, interact. So, for instance, the local plant for Lehigh Hanson is Union Bridge. And so each plant will have to be a type 1L, and then in parentheses, they're going to have the amount of limestone that they use. So for the additional amount of, or total limestone. So for Lehigh Hanson's Union Bridge, it's 10. So it's a total of 10% limestone. So each one would have to note what they use. And then, that's where, again, you can go up to the 15%. Typically, you'll see like a sweet spot between like 10 to 13% for most producers that I've seen, is typically what they'll have notated. But
Gotcha.
Yeah, I think they just needed to basically come to an agreement and a limit. We've seen where it's worked even higher, but that was basically what they agreed on with the certification and standard requirements.
I gotcha. And so the Portland Limestone Cement for Lehigh is produced at that Union Bridge facility.
It's at many facilities, but locally, as far as here in the Mid-Atlantic, Union Bridge, Maryland is one of our 1L producers here. Yes. Mm-hmm. So.
Okay. And when they start producing PLC, does they have to change the plant totally over to just PLC, or are they producing regular cement as well?
Currently, they are also producing type 1-2. The hope is that eventually it will completely change over to PLC. But there are other plants that may eventually, the way that the world is going with wanting to be eco-friendly and reduction in carbon emissions, type 1-2 is most likely going to be like a specialty product, that we don't have much of. Lehigh has several other plants that also produces the 1,2. So to have one plant completely change over to 1L wouldn't be an issue. But the great part too is that not only are we reducing emissions, and so when you use the more limestone, you use less of that clinker, which is causing the emissions and the burning of all these materials. But when you have this, you actually utilize less of these materials. So it lasts longer. You can make more because you're not utilizing as much, if that makes sense, with the least of that clinker process. So not only is it reduction in emissions, but it also prolongs the amount that we have as far as the materials that we're able to utilize and kind of stretch production, which is pretty cool. So it's kind of a win.
So we're just getting more efficient at making the cement is what this Portland Limestone Cement is helping as well, right? So
it does, yes. And then the cement itself actually can enhance strength. So it can do that in 3 different ways. So you can have with the limestone, you can have it's not just like an inert filler that doesn't like help in any way. It actually helps with particle packing, kind of like blending your aggregates together in the way that they pack together in concrete. So the limestone is softer. So when it's ground with clinker, it becomes smaller, and therefore it fills more voids between any kind of coarser cement particles, and helps create like a denser hydration process. And it also has additional nucleation sites. That's the second way. So it's for initiating the hydration process, which is like that initial process that occurs, like forming like the crystallization and the bonding and the strength enhancing for in concrete. And then there's also a chemical reaction. It's like a slight carbonate aluminate reaction with the limestone, which also can slightly increase strength. So you'll see enhancement with performance, with finishability, workability, even reduction in bleed water. So it's better for the environment. It helps with, as far as I guess increasing the amount of production that we can have, as well as enhancing the overall concrete itself. So it's pretty big win. So we're pretty excited about it, especially because it's just a 1-to-1 replacement. It's not something that producers really need to worry about. Even the local states, they're having us just do general trial batches where they don't even need. I mean, we always recommend that you would try and get your hands dirty with, to, I guess, say, with the concrete and the new material itself. You always should just run it through and see how it works. But states are even just letting us do just generic trial batches, rather than having to go to every single producer and every single plant like they normally would with a different product, because it's so consistent.
Yeah, so the Department of Transportation, they're the big, I guess, they're the ones that spend the most money on,
right.
Typically in each state. So are they all across the 50 states? Are all those DOTs, are they all on board with the limestone cement, or do you know where that is?
I think that as of now, I think we only have maybe 3 or 4 left that are still planning to accept. Actually, tomorrow I'm going to be doing, so they already had tested, so I'll be with Delaware tomorrow.
Oh, nice.
DelDOT. And they've already done their lab testing, just doing the side-by-side PLC versus 1L, or versus ordinary PC, but and showed that it was a like to like. And then now we're doing field trials. So I had done some, not last week, the week prior, and then I'm going to do another DelDOT test for a different type of mix. Like we had done standard ones, and now we're going to do their patching mix tomorrow. So they're just running field trials, just out of a lab, and then potentially to be good to go. And then the next 2 days I'll be with Maryland DOT doing the same thing. So they have already approved 1L, put it in specification, and now it's just going to be doing the trial batches so that all of the concrete producers don't have to test it themselves and resubmit. Basically, it's just going to be a paper change. So they can just resubmit their mixes. Instead of saying 1-2, it'll say 1L, and that's it. They won't need to. Yeah, it's pretty exciting. So, and Virginia's already been up and running. Same with Pennsylvania. We're currently working with DC as well. So it's pretty exciting. It's been pretty widespread. So, like I said, I think it's only just a handful of states that are still in the process of planning to accept, that haven't accepted it already. But for the most part, it's been accepted throughout the United States. So
I was just thinking about when you're driving down the freeway and you see those signs up that say testing. What's that sign? I'm trying to think of what it says. Have you ever seen it where there's like there's a section of the freeway, and it'll go from like asphalt to concrete, and there'll be a sign right in front of where it changes over, and it says like, whatever, NC dot North Carolina Department of Transportation. This is like a test or something. Do you know what I'm talking about?
No.
Have you ever noticed that?
No, but I mean, we see so much more now with concrete paving, which is awesome.
Right.
I mean, I do have a background as well in asphalt, but when you want something that's going to be structurally sound and last forever, like, your bridge or your overpasses and, things like that, you have concrete. Maybe it'll have an asphalt overlay, but it's concrete. So it's been pretty exciting to see, local roadways and parking lots and things like that kind of spreading into the concrete world, which is pretty exciting. But I don't know that I've ever seen that with the tests. I'm not sure that I have seen.
It's been a while since I've seen it. I think the last time I saw it was down in North Carolina somewhere, but I can't remember. Next time I see it, I'm gonna stop and take a picture of it.
Yeah, send it to me, please.
I will. So we were talking about so the Portland limestone cement. It sounds like it pretty much performs just like the regular cement that we've been using. So there's no difference. So my background's in buildings, and we do a lot of post tension. Structural buildings.
Yep.
And we're always focused on, the 2, 3, 7 day breaks. So are we going to see any kind of difference between the type 1L and the type 2 that we typically use, or no?
No, you're pretty much seeing a like for like performance, and sometimes you may even see an increase in strength. But sometimes enhance as far as durability as well. And you're also not really seeing anything as far as a difference in color or anything like that, because it's basically the same thing. So no, yeah, and we've had some just that have been seamlessly working with it already, and it's been pretty great. So yeah, I'd love to, this is one thing that I discuss. Whether I'm doing a presentation or if I'm just, having a meeting with like whether it's, pre-project or pre-pour or something to that effect. But, if you are ever partnering with a ready mix producer that you want to try it or get your hands on it, sometimes we'll do like lunch and learns where we can, pour some and just work with it and see it, or, kind of do like a test pour and just see how it works. But people have been pretty pleased. So, and most have just not even noticed. Some just put it in their plants and they just run with it, especially if it's just residential. They just, they just kind of go with it. So it's kind of just been a seamless change. So, and I know we had offline discussed earlier too, where, especially with projects and everything, it's always been LEED. Like everything's always been about having like a LEED certification. And that LEED was like 75% is operational efficiencies. But now, and only like 10% of that was like material. But now the focus is going to be on material. And the world's kind of changing now to requiring what's called environmental product declarations, or EPDs. And that's basically all on materials and embodied carbon and reducing our global warming potential. And with that, it's basically the entire process of how, you know, all of the materials are made, what kind of emissions, with the materials, like as they're being produced or as they're being used, and what's going into an actual project or building or structure. So it's kind of going to be the new way. It's been slow, but it's coming. So we're kind of seeing it already as far as what's going to be required. And it's kind of it's different for everyone. As far as, so you have to go through your what's called a life cycle assessment, or an LCA. So they have a production stage, construction stage, use stage, and an end of life stage. So for cement, they rate it based on what's called cradle to gate, or cradle to grave, like being the end of cycle. But the cradle to gate for cement basically is when you're mining the materials and you're producing it, and then it stops when it's going to be shipped, for at least for cement. That's when it stops for the production of the powder.
Right.
And then for a concrete producer, it's for them, and what they need to record is when they pick up or whenever it leaves a cement facility, whether it boat, rail, whatever, truck, doesn't matter. It's from then to when they then pick it up from like a facility, have it delivered to their ready mix plant, make the concrete itself, and then deliver that ready mix to a job site. That's when it stops for a ready mix producer. And then for contractors and anybody that's on site, it's from when it's delivered to you to basically that end of life cycle is your gate. But for a project requirement, whether it be owner or engineer, may require the whole thing. So you might need to get EPDs from the cement producers or any material that's going into the concrete, your admix, whatever. And then you're going to need to get one from the ready mix producer, and then have your own again for the building. So not every project is going to be the same. It's just a matter of finding out what they'll require. And obviously that's probably going to be a little different as the stage goes on. So that's why it's another important thing for us here, is that our reduction with global warming potential, it's kind of like a nutrition fact, how you'll see an EPD. I don't know if you've ever seen one, but it basically looks like a nutrition label. So yeah. Think of it as like the less calories, the better. So the lower your GWP, the better, as far as, for reporting for your project. So that reduction in your global warming potential, the better. So sorry, I just wanted to make sure I touched on that.
We were talking offline. We'll have to explore that together on another episode, because that's definitely interesting that we are again focusing on this, and this is April 22, and I was LEED accredited back in the day when that was the hot and heavy thing that everybody was getting involved with. And I think that was, I feel like that was like 07, 08 maybe. And there was a lot of focus on that. And there, like you said before, there very little focus was put on where the material was coming from. I remember those were the easy ones to get, right, like the credits for that. It was like, if you get the material within 500 miles, you're good to
Yeah, you're
go.
good. You're good to go. Right.
So
Yeah.
back then I was building precast garages. So the precast guy was all within 500 miles, and then you get the rebar guy, and he's close by, and so concrete we were always good.
Yeah.
So
Right.
and
Now
that
it's
was it. And then everything else it was the GC's problem. So uh,
right. So now it's getting into the nitty gritty. So it's like,
now
okay,
the focus is again on concrete, and again, this is all because concrete is so widely used, right? It's the
yes,
most used material on earth. I was
it
looking at
is.
a graph from the Portland Cement Association. They have a graph, and it shows how much concrete is produced compared to oil and coal, and those two things are lined up with each other. So as much oil and coal that's produced on Earth, that's as much concrete is
Right.
used on Earth, and it's because concrete's easy to use, right? And you
Very
can
versatile.
and for the most part, you can make it anywhere in the world.
Hmm.
Um, so you can find the sand and the stone and the cement to produce it, and it's not like you're dragging, and I don't want to start anything, but you dragging steel or pieces
Right.
of mass
We
timber
could talk
across
about
the
all that
world.
stuff. Right.
And
For
I'm
days.
starting to show my bias, so that means that's probably we need to get to the end of this. But the Portland limestone cement. Is there anything else that you typically go over? I know you do these presentations all the time. Is there something
Yeah.
else
I'm
that
just trying to think.
for us amateurs when it comes to the PLC? Is
Um,
there anything else that we need to keep in mind? And obviously we need to be on the lookout for this in our specs. Um,
yes, for
and
sure.
uh, and we need to start educating our engineers on this. I'm sure they're learning about it as well. You probably give these presentations to a bunch of structural engineers and say, hey, we're just
Yep.
swapping cement, and
Yep.
it's good for the environment. And you were saying before, it's been used for what, like 10 years, you were
Yeah.
saying?
That's just the US. I mean,
US,
in Canada and Europe, it's been used for much longer than that.
right?
Much. So we're kind of at the tail end, just getting with it, basically.
Yeah,
And usually, so it depends on who I'm presenting to, obviously, whether it be engineers to kind of just show what the difference is with the specification and why they basically don't need to worry about it between the C595 to the C150 and things like that, or with contractors on how to help with getting it specified, or with producers on how they won't. So, for instance, we've done testing showing that I think the set time, like for instance, like one was like an 8-minute difference. Like it was all basically very negligible. And then as far as I want to say the slump was the exact same. The error was a difference of like 0.2, 0.3%, something like that. Again, extremely negligible. And you're seeing your same, if not better performance as far as strength and the workability and things like that. So that's basically been the biggest thing, is just to show that this is like the easiest way you can help reduce your carbon footprint with producing concrete. So that's basically been like, I guess, the biggest thing. And another thing that I would say is there's resources out there too. I mean, I'd be happy to most certainly team up with a company, do presentations, whether it's in person or virtually. But also, like you had mentioned, Portland Cement Association, you can go to it's greenercement.com and you can learn all about PLC. Kind of all the background and frequently asked questions and things like that, even where it's a map of where it's accepted. So it's very informative. And then I think they even have how to specify it and different fact sheets, things like that. So, and by all means,
yeah.
please feel free to share the information.
Since you're offering, if folks want to, after they listen to this, if they want to get a hold of you, what's the best way?
So my cell phone is 443-714-0469. And my email is Stephanie, STEPHANIE .Hampton, HAMPTON, at Lehigh Hanson, LEHIGHHANSON.com. Or you can find me on LinkedIn, Stephanie Hampton.
That's how I found her. Then yeah, that's great. And I'll put all that in the show notes so people don't have to listen to the podcast 4 times trying to write that down. I'll put it in the notes. Stephanie, I appreciate you coming on the show and let me record you. And like I said, we'll have to get up again and talk about EPDs and all that other good stuff and let you share more of all that knowledge you got.
Perfect. I'd be happy to do it. Thanks for having me. I appreciate it.
Yes, ma'am. Thank you.
Mm-hmm.
Hey everyone, I hope you enjoyed today's episode of Concrete Logic Podcast. If you did enjoy, please hit subscribe on your favorite podcast listening app and share with others that you would think would find value in the podcast. I look forward to having more discussions. Please tune in and we'll see you on the next episode of Concrete Logic Podcast.